Hello everyone, welcome to this week's video. In this week's video we will be introducing 7-digit numbers. So we've seen some of these numbers before, now we will study them in more detail. So up until now we know about 5-digit numbers, so we know up until tens of thousands. Now we will be talking about the next digit, which is hundreds of thousands, and the next one as well, which is millions. So as you can see here, we have numbers that have 1, 2, 3, 4, 5, 6, 7 digits. We know that on the far right are the ones, as they've always been. Then we have the tens, and we have the hundreds, and the thousands, tens of thousands, hundreds of thousands, and then millions. And as you can see, after 6 digits, so 1, 2, 3 is the thousands, right? We put in the dots for the thousands, and then another 1, 2, 3, and we put another dot, and that dot is for the millions. Now, what I want us to do here is I want us to try and read these numbers together. So the process for doing that is similar to how we read thousands. So when we have millions, we basically try to read the number that's in front of the millions dot first as if it's alone. So here we would say 8, then we would read the dot as millions, and we'd say the next number, so between the dots, right? So 635. Then we read the thousands dot as 1,000, and then we say the last number, so 529. Altogether, we would say 8,635,529. That's how we would read this number. I do want to point out something that is something that you have to be careful in Greek. This isn't a concern in English, but in Greek it is a little bit. So in Greek we would read this as, I'm going to say this number first in Greek. So here we would say 8.635.529. But this one we would say 1.εκατομμύριο. So notice that before we said εκατομμύρια, πολλά, whereas here we say εκατομμύριο because it's only one, right? So it's the same with the thousands when, for example, I have to read a number that only has 1,000 as opposed to when I read a number that has many thousands, so like 4,000. In Greek, this would be 1,523, and this would be 4,625. So notice that difference, and also notice that it carries on into the millions. Right, so let's continue in English from now on. As we said, we read the number in front, so 1,205,689. Next, we would say 5,420,954. For this one, we would say 7,300,600. Now here is a tricky one where you might get confused if you see just zeros for the rest of the number. So what do? Do you say 9,000,000? No, you just say 9 million. When you say 9 million, it is implied that, well, since you're not saying anything the hundreds of thousands or the tens of thousands or the thousands or any of the other digits, then they're all zero, right? So Here, for example, we would read this as 1 million, right? Now let's say someone asked you for this number here. They asked you, okay, how many hundreds of thousands does it have? Well, you would have to say, well, this is, let's go to the digit that is the ones, right? Sorry, the hundreds of thousands. We start off ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands. This is it. This 3 is it. Or you could have skipped the first 3, since we just say these are the thousands right after the first dot. And these are the thousands. So these are the tens of thousands, hundreds of thousands. So you would say this number has 3 hundreds of thousands. What if they asked you for this number? How many millions does it have? Well, you can just look at the number that's in front of the millions dot, 5. Or if you wanted, you could start from the far right and say ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions. And as you can imagine, this process does repeat into numbers with even more digits. So let's just put a number here. Let's just put an 8, right? So if I want you to notice this process of 3 numbers dot, 3 numbers dot. This can continue further for as much as we want. So for example, we already know 8,000, right? We know that. And now we learned 8 million, right? But what if I add another dot and another 3 zeros? This would be 8 billion. And we can do this again and again and again for as many times as I want. But that's something we're going to talk about another time. Next up, let's move on to the exercise. I want you to try and do the exercise on your own. So pause the video and try to find the next and the previous of each of these numbers. So try and do that on your own. It might be a little more challenging than you think. All right, so now if you're back, I'm guessing that you tried to do these on your own. Let's see if you got them correct. We will begin by doing each number separately. So here we have 5,260,425. To find the next number, we just have to make the ones increase by 1. So from 5, they need to go to 6. All right. So we're going to copy this. But instead of 5, we're going to put 6. Okay. So the next one from 5,260,425 is 5,260,426. What about the previous one? Well, as you can imagine, for the previous one, we just make the ones go down by 1. So instead of 5, they're going to be 4. So if I was counting and I was all the way 1, 2, 3, 4, 5, and at some point I reached 5,260,424, I would say 5,260,424, 5,260,425, 5,260,426, right? Now this is where it starts to get a little more tricky. Here we have 1,405,999. Now watch what happens. We just said that if we want this to go up by 1, that means that we need to make the ones increase by 1. Okay, so does that mean that 9 is going to become 10? So should I write this? Is this a correct answer? The answer is no, of course not, because you can only replace it with one number. Like you can't just put in 2 digits from nowhere. So no, we could not do that. What happens here basically is that because I added 1, right, this becomes 10. A 10 is, well, a new 10. So I need to carry it over to the tens. So I need to increase the tens by 1, right? And then tens become, instead of 9, they become 10, which creates a new 100, which I need to carry over to the hundreds. And now the hundreds become 10, and I need to carry, which creates a new 1,000, which I need to carry over to the thousands. Imagine that it's like a domino, right? So the first one just gets knocked over, right? Comes 10, which increases the tens by 1, making them 10, which increases the hundreds by 1, making them 10, which increases the thousands by 1, making them, well, here it stops because thousands just become 6. Nothing needs to get carried over. So the next number after this is, again, imagine if these are dominoes, right? We add 1, the 9 becomes 10, so I write 0, carry 1, and then the tens become 10, so I write 0, carry 1 again, and then this 9 becomes a 10, so I write 0, carry 1, and this 5 becomes a 6, and we stop carrying over. Now, to find the previous number, that's a lot simpler. We just make the 9 go down by 1, so 8. So that's something that you should keep in mind. Now here you can see that the same thing is going to happen again. So let's find the previous number real quick. So I'm just going to decrease the ones by 1, make them 8. So 6,999,998. But here we are going to have the same domino effect, where one regrouping causes the next, and then the next, and then the next, until they meet a number that is not 9, basically. So here we're going to have 6,999,999, and if we add 1, that creates a domino, basically, where I get 9 plus 1 makes 10, so I write 0, carry 1, and then the one that I carried over plus this 9 makes 10, so I write 0 again, carry 1, and again 9 plus the one that I carried over makes 10, so I write 0, carry 1, and again the same, and again the same, and again the same, so I end up having to add 1 to the 6 and making it 7. Which kind of makes sense if you think about it. Like the next number after, like, let's say 59 is 60. And the next number after 599 is 600, right? And the next number after 5,999 is 6,000. Why is that? Well, that's because of this right here. That's the same thing that's happening. Adding 1 to the ones is creating this domino effect that increases all the digits after it by 1 until they meet a digit that doesn't need regrouping, basically. So 5 plus 1 just makes 6. There's no need to regroup after that. Now here we have the opposite happening, where it's easy to find the next number because I can just add 1 to the ones. So this is going to become 4,405,001, right? But what about the previous number? So up until now, we said that to find the previous number, you just decrease the ones by 1. Now there's 0. So what happens now? Well, imagine if this was subtraction, right? Like a vertical subtraction. And you had to subtract 1 from here. What would you say? You would regroup. And you would turn this 0 into 10 by borrowing 1. this would become 10, right? And you take away 1 and make it 9. But then, because you borrowed, you need to subtract 1 from the next digit. So from this 0, which you can't do again. So you'd need to borrow again, and this would become 10 minus 1 would become 9. But because you borrowed again, you need to subtract from the next digit as well. So you'd have to do 0 take away 1, which again you can't do. So again you have to borrow, and this becomes 10 take away 1 makes 9. But because you borrowed, you need to subtract 1 from the next digit from the 5. But you can do 5 take away 1, it just makes 4. Right? So again, we have this domino effect where because you needed to regroup once, it caused all the next digits to regroup up until you met 1 that didn't need regrouping. You could actually subtract 1 from 5. So the previous number before 4,405,000 is 4,404,999. You can imagine here that this is going to happen again from all the zeros. So to find the next number, I'm just going to add 1 to the 1s. It's going to become 8,000,001. But to find the previous number is more challenging. Because what happens? I need to take away 1 from here. And again, I can't, so I borrow. So I say 10 take away 1 makes 9. But then because I borrowed, I need to subtract 1 from the next digit, and it becomes 9. And then the same happens to the next digit, and then the same happens to the next digit, and the next digit, and the next digit. But then you meet this 8, which doesn't need regrouping, so you can just say 8 take away 1 makes 7. So the previous number before 8 million is 7,999,999. All right, well, that will be all for today. I will see you guys again in tomorrow's video. Have a good day. Bye.